Hello, in this C programming video, I am going to cover arrays. So if you want to know more about arrays, this is just going to be a basic video. Feel free to watch these subsequent videos that I create as well. In here, we'll create a one-dimensional array. I'll explain what an array is, and I'll show you how to access the values. So what is an array? It's a collection of values, and they all have to have the same type. So integer, char, that sort of stuff. And they're used for let's say if you have high scores in a game, for example, you know it's common data. Store them together instead of creating 5 variables: high score 1, high score 2, high score 3, high score 4, high score 5. We create like a high scores array, and we have 5 values in there. A size of 5, and we can easily move that around. We can pass that to functions. Just pass one array instead of passing 5 values. And if it was a 100 size array, 100 elements in there, elements is another term for the values in there, you just pass the one array. You don't pass in 100 different variables to a function. So you can see just right there, the huge benefit of it. Like I said, the data type has to be the same for each value. Can't mix and match with integers, chars, that sort of stuff. Has to be one, and the size is fixed from the initialization of the array. And yeah, let's get to it. So to create an array, you put the data type, put the name, then put high scores, and then you put square brackets, size of the array, so 5, semicolon. For some reason, VS Code is giving me this BS unknown word. Ignore that. I mean, if you get that, ignore it. I mean, compile's fine. I don't know why it's giving me that, or the editor does not. And to access one of the values, or to overwrite it, you put high scores and put square brackets. And to access it, you access it 0 through to the size -1. So in this case, it's 4. So 0, 1, 2, 3, 4. Because stuff in computers generally start at 0, the first element is stored at 0. So you put 0. And let's say that's the high score. We're going to put 1,000. And I'll duplicate this. So we have a total of 5. And the second element is stored at index 1. Third element is stored at index 2. Fourth element is stored at index 3. Fifth element is stored at index 4. And let's just change these: 8, 7, 3, and put 299. So close. And now to use them in a way that you let's say print them out, for example, you put, let's say, printf. And let's say if we put %i, put \n, so it's on a new line. And I'll actually put 1. I'll put number 1. And to print it out, you literally just do the same here. So square brackets I. You can't just put high scores and think you'll print all of them out, because it doesn't know what you're trying to do. You have to be very explicit with programming, especially with a language like C or C++. So we'll print this out: 2, 3, 4, and 5. 1, 2, 3, and 4. Print it. Run it. See what we get. So we get 1,000, 800, 700, 300, 299. Pretty cool stuff. So right now it's pretty easily, traversable. That's what it's called. You're traversing the array. But if you've got 100 elements, you don't want to be doing this. 1,000 elements? Hell no. So you can loop through the array. I will cover that in a separate video. I think that's a separate topic in itself, or subtopic. But what I was going to show you is you don't actually just need to do it like this. So if I comment all this out just up to here, and what you can do is say equal on the same line, curly braces, and then put the values here. So I could put 1,000, 800, 700, 300, and I'll do a slight difference so you can see that it is different. 298. So they're running the old code. As you can see, that works fine as well. So obviously that's fine if you initially know the values, and you can actually put, and here or there, you could put a variable. So you could put something like, say, int score. Maybe it's been passed in. Let's say that equals 1,000, and you could put score there, for example, and you could put it there as well. I'll run that. What's it moaning about? Hmm. Expected identifier or before numeric constant. Hmm. Yeah, works fine now. I mean, I don't know why. I mean, to confirm that it isn't running old code on that. And see, it says 1200. So I will get rid of that. You can just see, that works fine. Probably just some BS error. The other thing that you can do is if you know the values that you are initializing the array with, you can just get rid of the size because it will explicitly get the size based on the number of values. So if you know that you're going to get all the values initially, and that's the total amount of values, so 1, 2, 3, 4, 5, you can do that. If you run it, you'll still work the same way. So you can also do that with an array as well. I prefer to be very explicit like so, unless the only time you wouldn't is if when you're coding it, you don't know necessarily how many values are going to go in, but or let's say if it's getting created in a function, for example, set up in a function, you let's say know that it's going to get all the values initially passed in. And you might be 5, you might be 10, and then you're going to use something like a loop to be able to go through every single value. Then I think it's useful to omit it. Otherwise, I would like to be as explicit as possible. So when you're scanning code, it's easier. Instead of being like, okay, there's 1, 2, 3, 4, 5, or 10 or 20 elements, be like, okay, 5, 10, 20. So that's arrays, really simple stuff. There's 2-dimensional, 3-dimensional. After that is where it gets, really, mind tricky. And so, yeah, that's arrays. If you have any questions, feel free to post them in the comments. There's a link in the description to the GitHub page where all the source code is. And as usual, if you like the video, give it a thumbs up, hit that subscribe button, and I'll see you soon. Bye bye.